Hi friends, welcome back to our channel. Hope you are all good. Today I would like to discuss about multiplier. That means how to multiply two n-bit binary numbers. Let us see how to do it. Yeah, I am considering two 2-bit numbers, that is a1 a0 into b1 b0. It's just a normal multiplication. A1 A0 into B1 B0, like 112 into 13. How we will do multiplication normally? In the same way we will do in these binary numbers also. So now A0 B0, A1 B0, A0 B1, A1 B1. Now adding A0 B0 will come as it is. Let us assume the output as Y0. Okay. Here Y0 equal to A0 B0. A1 B0 plus A0 B1. It requires one half adder. Is it correct? These both are two 1-bit numbers, right? A1 B0, that is AND gate. If we perform AND gate for A1 and B0, the resultant is A1 B0, that is 1 bit. And if we perform A0 into B1 by using AND gate, then the result will come as 1-bit number, right? So we are using half adder. Half adder means, as we discussed before, it adds two 1-bit numbers. What's the result? It will give sum. So I am assuming sum as y1 and carry as c1. Now, in the same way, it requires one half adder. So we get sum as y2 and carry as c2. Now the C2 comes here and the final result is Y3, Y2, Y1, Y0. So this is how we perform multiplication in binary numbers. Now let's try to implement the code.
CDA playground where we write design and test bench code. As we saw before, to implement the multiplication, we need AND gates and half adders. So first we need to write half adder code. I am opening a new file and naming it as half adder dot p dot sv or v. It's not a big deal. Or click on create file. Now we got it. Just I'm writing half adder code as we discussed before, so I'm not going to explain this half adder. See out some of the outputs. A is the input, B is the another input. Declaring inputs, declaring outputs. To get some, we need to perform XOR operation. Sum comma A comma B. That's it. That's it. Our half adder design. So I'm implementing the main code, that is multiplier. So module mul 2-bit I just named because we are multiplying two 2-bit numbers. So I'm declaring output y, input a, b. A, b are inputs, output is y here. As we know, we are multiplying two 2-bit numbers, so we need to take a as 2 bits, b as 2 bits. So that's why I'm mentioning input wire 1 down to 0. That means a of 0, a of 1. The above line we can write it as wire input wire 1 down to 0 a, and again declaring input wire 1 down to 0 b. In this way also we can write declaring output sorry output wire 3 down to 0 y. Why I am using output as wire here? Because I am not using any sequential circuits here. These are all as we know, half adder and gate, these are all just combinational circuits. So we don't want to use ridges here, we don't want to use any memory element here. So that's why I used wire. And also we are not implementing any always at postage clock or always at star. Just I am using assign blocks or normal instantiation methods. Again I am repeating how to multiply. That is, suppose if we consider a1 a naught into b1 b naught, we multiply b naught with entire a inputs. That is, we will get as a1 b naught and a naught b naught. This is first row. For that row we need to write Verilog code. That means to obtain a naught b naught or a1 b naught we need AND gate. So I am using AND gate. Some 0 z of 0 0 I am giving. As we know, a naught b naught is same as y of 0, right? Y of 0 comma, what is the input? A of 0 comma b of 0. Okay, and then and again AND gate to perform a1 b naught. Here I am assuming output something as P10. You can assume anything, it's not a big deal. That's it, our first row is completed. Now we are multiplying B1 with entire A inputs like A1 B1. Sorry, A not B1. This is second row. Writing Verilog code for this. And of Z of 01. Some output like P of 01. Now we need half adders, right, to add A1 B0 with A0 B1. So I am using half adder here. Here we wrote half adder code. This line we need to take it out. I'm copying and pasting here. Okay, this should be the same. Okay, we need to give instantiate here. That is by giving some name. I'm giving ha1. You can give any name. Yeah, I am assuming cout as, what is the carry that we got before? C1, and sum is y of 1. When we will get this? By adding a1 b0 and a0 b1. So what's the output of a1 b0 p10? What's the output of a0 b1 p01? So those are the inputs for this half adder. That is p10 comma p01. Again another half adder. Some ha2 carries c2 y of 2 is the sum. Now we are adding p11 and this carry p11 and this carry, that is c1. This c2 we assign to y3. So I am writing just a send statement, y of 3 equal to c2. That's it, our design code. It's easy thing. Here I did one mistake. If you are good, please identify that. Later I will tell you what is the mistake here. Now I am writing test bench. Module db input test edges edge 1 down to 0, a comma b, down to 0, y. Now instantiating. Yeah, till now we how we saw to write test benches. We are giving inputs like a equal to 0, b equal to 1. Every time we are specifying some value to the inputs by using our analysis. Let us try to give some random values. Let us try to pick some random values by simulator itself. To do that, we need to give just repeat statement, that is repeat. I'm saying simulator to provide 5 random values 5 times. Okay, repeat 5. Yeah, here what I did is I said to simulator to provide 5 random input values to a and b. First, how it will start? It will start initial block at time 0, and then it will enter to the begin end. So it will see this statement like repeat 5. Okay, simulator will remember that. Okay, we need to give 5 input values. So first time it is doing, it's like a loop. Oh, so it will assign a to some value like a equal to 2 and b equal to 3. It will print the results on the output screen, and then again it will assign some value to a and b, and again it will print the results. So like this it will repeat 5 times here. After begin end, I am providing here. For this begin, we wrote end here. For this begin, we wrote end here. So definitely we need to end with end. It's a end keyword. So end module, that's it, our test bench. So I'm just selecting the simulator, that is Synopsys PCS. I'm just checking whether the language is in Verilog or System Verilog. It is in System Verilog, that is fine. And if you have any queries regarding this video, please let us know in the comment section so that we will definitely try to help you out. Thank you very much, guys, for your patience. Thank you. Bye. Now we will try to run the simulation. I'm clicking run button here. Let us see what it will show. It is showing error as unresolved modules. Why? Half adder we wrote code, but also why it is not taking. It is saying that module definition of above instance is not found in the design. So what we did is we wrote half adder here by creating a new file. To get this half adder into this design file, we need to include this name we need to give, that is half adder.sv. Now let us try to simulate again. Just only one statement. We will save this and then we will run. Yeah. See, the simulator itself assigned A as 0 in the first iteration, B as 1. 0 into 1, as we know, y equal to 0. Second time it assumed A as 1, B as 3. So y equal to 3. So in the same way simulator itself assigned 5 values. So this is about multiplier. Thank you very much guys for your patience. If you like this video, please share and subscribe to our digital VLSA channel.